Afternoon. Welcome to today's Liftoff webinar. Thank you for joining us. My name is Christine Longroy, Senior Director of Ecosystem at Lyft. As I said, thank you again for joining us today. It is our pleasure to have James Heckendorn from Siemens Digital
Welcome to Liftoff Webinars, brought to you by LIFT, the National Advanced Material Manufacturing Innovation Institute, where we drive American manufacturing into the future through technology and talent development. LIFT is a public-private partnership where we convene and connect government, industry, and academia in the fields of advanced materials, manufacturing processes, systems engineering to enhance America's manufacturing competitiveness, national economy, and national security.
Thank you for coming to today's webinar. My name is James Heckendorn from Siemens Digital Software. I've been with Siemens a little over 6 years working in the additive manufacturing space, and I'm going to be giving you guys the presentation today on NX additive manufacturing with generative engineering. So one of the things about Siemens, right, we have a very wide portfolio of software solutions, and one of the things that really enables our customers to navigate through the additive manufacturing space is, right, taking kind of whatever route through using whatever design, simulation, manufacturing tools along a digital thread to best optimize and address kind of their solution issues. A lot of the things that we see out there in the industry in terms of challenges with additive manufacturing kind of surround this idea of that digital thread where disconnections, right, import, export, file conversions, and workflow issues really are a barrier towards kind of industrializing that additive manufacturing technology and really extracting as much from that, right, that we can. Kind of in the graphic here in the bottom left-hand side of our screen, right, is very indicative of what we see out there in the additive industry today, where, right, there's a lot of different kind of software packages, a lot of import and export that kind of comes, right, with the different buckets of additive manufacturing. And so one of the things, right, that we pride ourselves here at Siemens is kind of that end-to-end digital thread for additive manufacturing. This slide here is kind of a sampling of a lot of the different buckets, right, of functionality that we have in kind of that end-to-end portfolio. And it's going to be a guide for our kind of journey down this webinar today. right, we're going to cover a lot of the design for additive tools and some of the other applications on kind of our Xcelerator platform that can greatly enhance your additive workflow. And right, you'll see a lot of value in terms of the connectedness of a lot of these solutions and how we can reuse a lot of that data downstream, without any conversion. Right, so we're going to kind of take a look at the planar additive manufacturing use case today. Right, we're going to kind of start in the design space and progress through some of those other, downstream applications, build preparation, simulation, and manufacturing integration. So this is going to be, again, our kind of guide for the presentation today, and kind of keep in mind these highlight bullet points right down at the bottom of a lot of the value that you'll get throughout, using these different applications, and how naturally kind of a lot of that data flows from one into the other. So in order to leverage additive manufacturing across your workflow, right, this is kind of a little more graphic slide than the one that we just looked at, right, where it incorporates a lot of the different aspects of the Xcelerator portfolio in NX, right, using kind of that core traditional modeling environment, but integrating it with a lot of the other tangential pieces that come into play with additive manufacturing, where we're doing design space optimization, embedded CAE analysis and material science, right? Also kind of leveraging new technology from artificial intelligence and machine learning to really enhance your workflow. So when it comes to design for additive, right, a lot of that kind of traditional design methodology gets replaced a little bit with, what are the actual performance and functional requirements of my design, where those really drive what the end result of your design is. And this is kind of where we take a lot of those different tools from generative engineering, topology optimization, embedded CAE, and kind of combine them together in a system context where we can incorporate a lot of those different aspects to create that particular design. And of course, kind of as I mentioned, a lot of that flows down into our other applications for actually, planning for the manufacturing, for validating those designs, data storage, and again, a lot of those kind of insights from, machine learning and production performance. So to kind of start off in the core design realm, NX utilizes a lot of those core best-in-class design capabilities that you'll see in a lot of different CAD packages, as well as a lot of different capability from synchronous modeling, advanced sketching, and a lot of things that come into play with additive, from reverse engineering, working with scan data, quality and definition of our eventual designs. And so there's a whole career's worth of capability I could talk about inside of NX for incorporating kind of traditional design into that eventual output. But one of the things that really comes into play with additive is those kind of core functional requirements. And so one of the things that kind of we've developed over the last few years is this capability to do multi-objective design, space exploration, and incorporate that with a lot of our other additive applications, where we can utilize those embedded parameters within your design context and kind of search through that design space to arrive at that optimal design, utilizing your goals and objectives. And this is an application called NX Design Space Explorer, It's designed to kind of utilize your core design parameters and features that go in there, explore that range of design space that you may define, what are your constraints and objectives, and then kind of search through that to arrive at the best optimal design utilizing those different parameters. And again, you'll hear me talk about this a lot today. This is where we incorporate that with a lot of our other kind of advanced CAE, or this HEEDS capability that we talk about is kind of that automated iterative feedback loop of we're going to test, evaluate, and then use that to refine our search. So this is a relatively new application that has gone into NX for looking at a lot of the possibilities that you can define kind of using that traditional design process. And again, kind of to add on to that, right, another thing that we've developed in terms of that NX portfolio is this application we call NX Performance Predictor, where it'll give you real-time feedback in the design phase, right? We set up a simple CAE analysis that'll run, right, iteratively whenever you change the actual design of your part, right? So we can explore a lot more, prototypes and concepts and get real-time feedback. You're seeing on the screen, right? It's evaluating the maximum displacement and stress, right, of our design. It's doing this in the design application, right? Once we set it up, it'll just constantly refresh itself once we make a change to our design. So really, right, we can kind of arrive and get that feedback on what our design's performance is going to be without having to, right, go through, multiple loops, right, with a CAE analyst, for example. Kind of what that looks like, right, visually here is, right, kind of that traditional method of making design iterations, simulating those, right, and then kind of incorporating that into our release design, where what Performance Predictor is designed to do, right, is every time you change that design to give you that, right, early on feedback on what your design is actually going to do performance-wise, so we can arrive, right, at that eventual design much quicker. Kind of along the same lines, right, of giving you that feedback early and often inside of NX, right? We've had topology optimization, right, baked right into NX for years now, right? It's a embedded, right, product in the design world, where we utilize functional requirements to, right, optimize the geometry of components or assemblies, right, to perform what-if studies, and, right, to generate an output that we can consume downstream in a lot of these other applications, right? It's kind of fully baked into NX. This is where we specify, right, kind of what our functional requirements are, what kind of shape constraints and manufacturing methods we want to use. And, right, we're going to let the system kind of do the work for us and arrive at that geometric solution that best solves our problems. I kind of mentioned, right, the component and assembly optimization, right? This is where we've, over the years, we've had this inside of NX, enhanced that capability. Almost every single major release we do, right, to look at other use cases within additive manufacturing, whether it's multi-component optimization, right, multi kind of design space optimization at the same time, differing materials, other optimization methods, right? So we're kind of bundling a lot of this functionality. And again, we do it right in the design process. And so kind of what we've looked at so far is that ability to kind of explore your design space and arrive at that solution or optimized solution, right? Give real-time feedback on what that performance is. And then, right, based on that, we can go and kind of further optimize the component or the geometry using kind of this embedded topology optimization. Right, one of the things that in additive manufacturing you deal with a lot, especially when it comes to topology optimization, is working with facet data and mesh geometry. Whether it's from topology optimization or, right, reverse engineering, or getting quality inspection data, or, right, an output mesh from CAE, right? It's a common data format that we work with all the time. And, right, baked right into NX is this capability to do, right, direct mesh editing. Kind of think of your classic, right? We're going to clean up, smooth, fix, fill, snip, right? Kind of those direct facet operations. But one of the most powerful things about NX, right, is this capability called convergent modeling, where we can do, right, parametric feature-based modeling directly on facet data. Again, we can consume it and use it downstream, right? We're putting parametric features on mesh data so that, right, we can just kind of perform the action that we need to, and then, right, move on throughout the rest of our process, regardless if it's facet data or not. right? Kind of just to continue expanding on that, right? What that optimized output or right working with those parametric features on a mesh basis looks like, right, is we actually retain a lot of the analytical faces and features that, right, we either inherit from the optimization or that we apply from creating those parametric features on our mesh data, where, right, we inherit materials that because they're true, right, analytic surfaces or features. As you can kind of see in the right-hand corner there, right, we can do things like assembly mating, right, PMI and dimensioning, feature-based machining, again, other measurements. So there's a lot of capability that we can bake in with that convergent modeling capability. I have to snip that one out. Right, some other design for additive capability that also comes into play outside of, right, working with mesh geometry is working with lattice structures and what we call implicit geometry, where, right, we may design additional features right after we've gotten out of the optimization process. We want to kind of further refine and enhance our design for, you know, the manufacturing process. Again, baked right into NX, we have applications for, right, generating right, rod and ball kind of traditional lattice structures, as well as kind of that implicit modeling environment that you're kind of seeing in the upper right-hand video here. This is where we do all of our TPMS structures, as well as, right, kind of give you that freedom and flexibility to author your own you know, from kind of whichever perspective and kind of equation based that you know, you're incorporating into that design. Other things, right, that come into play in design for additive that we've kind of enhanced and created over the years is this algorithmic modeling environment kind of down in the bottom right hand corner. And this is where, right, we kind of stack that you know, node-based structure into a logical rule that we can apply with a drag and a drop, and it's going to do a lot of advanced design capability for us, right, that we can kind of store in a reusable object and then, right, consume over and over and over. And so it kind of opens up, right, the capability of NX, right, a lot of that core design as well as added design capability you'll see in that environment, and we can kind of bundle up, right, those complex patterns or, right, common workflows into this algorithmic capability that users can just drag and drop and easily apply onto a particular design. Right, other things that also come into play with additive, right, is kind of doing a lot of prep work for manufacturing, right, serialization. And again, I kind of mentioned this earlier, there's a whole career's worth of tools inside of NX here that I could talk about, you know, that kind of touch a little bit of that design for additive, again, kind of that design for additive workflow. Right, I kind of mentioned validation a little bit. This is where, right, we kind of at this point in our journey, right, we've looked at our kind of design space and functional requirements, right? We've done some optimization, we've done some further refinement of that design, right? Using tools like implicit modeling, convergent modeling, and algorithmic capability. You know, at this point in the process, right, we move on to kind of that validation of our part for the actual manufacturing process. And one of the things, again, I mentioned earlier is the topology optimization environment utilizes that capability, right, of the manufacturing process and kind of designs that in to the actual, you know, product there, right, when it does the optimization. But with, you know, a lot of the other use cases in additive, right, we want to validate that before we actually get into the print, right, preparation or right onto the actual build plate. And this is where kind of the NX design for additive manufacturing validation tools come in, right, where again, still in the design modeling world of NX, right, we can look at common manufacturing issues of our designs, right, like overhang angle or right minimum wall thickness, minimum radius, orientation optimization, right, trap supports and powder, right, a lot of those different gotchas that can come up in the manufacturing process, right, we can analyze and account for kind of, again, early in the design process, that, you know, like the performance predictor where it gives you real-time feedback, right, these live with your design, so that as we make changes to that, right, these results update and we can see that information, again, as we change our design throughout our workflow here. Kind of, right, moving on, right, once we look at that analysis for the manufacturing process, this is where, right, we may want to do further actual advanced design validation, you know, advanced physics simulation. And again, on the NX platform, right, just a different application we call SimCenter 3D, where again, we can do our, right, fully baked CAE analysis, verify those optimized results with our requirements. And again, this is where kind of where that data transfer, right, comes into play is we don't have to, right, import, export, or do any, again, kind of data transfer. It just consumes the data that we've created in modeling, right? In an optimized structure like this, right, we can utilize the exact same mesh, right, that our optimization engine outputs, and consume that, right, in some of these other advanced physics simulations, right? This is kind of where we get into the, right, multidisciplinary optimization component of the presentation here, right, as well as our other kind of advanced physics simulations that you see on the screen. Right, kind of along those lines, right, once we've validated our model, right, this is where, again, in kind of the same breath, right, we have that collaboration with our manufacturing applications, whether it's model-based definition, whether it's, you know, build preparation, whether it's post-process machining, right, in the same way we consume that data in these other applications of, right, the NX platform, so that, right, we can just take that data, again, account for that particular area that we're looking at, and then move on with our, you know, broader workflow here in additive manufacturing. Again, I mentioned a little bit of that, right, orientation optimization, right, that's something that we consume in the manufacturing environment so that as we, right, design and find that particular orientation, right, we have it saved so that we can just reference it later. You know, likewise, you're seeing on kind of the upper right-hand video there, right, our integrated tools for creating PMI and model-based definition, as well as doing that, you know, kind of autonomously with some of that, you know, node-based algorithmic capability. Right, one of the big things in additive manufacturing as well is validating the actual process, right, avoiding kind of, you know, scrap and potential rework and getting to that first time right print. And this is where, right, kind of that component of, right, our embedded CAE tool inside of NX looks at, right, what the actual process is of producing the part on the machine, where, right, in the laser powder bed fusion use case that you're kind of seeing on the screen here, right, we can simulate that build as it gets built, looking at things like, right, you know, the powder, the thermal distribution, right, if we have multiple parts kind of nested right inside of that build, multi-laser scenarios, right, again, looking at distortion at different stages of the process during printing, again, cool down, support removal, heat treat, stress relief, and you get a lot of information that comes out in terms of, right, are we going to have potential recoder issues, right, are we going to have any shrink line prediction, as well as kind of on the bottom right-hand graphic on your screen, you're seeing kind of that compensation workflow, where we can take the results of all of these, you know, simulation output, right, that thermomechanical simulation, and we can distort our original part so that, right, it arrives as close as possible to that nominal geometry. Again, other things that kind of come in here, right, is we can actually have that iterative feedback loop that's baked right into this application and capability where, right, we can simulate that build, we can distort it, and then, right, run through that loop multiple times to optimize, right, our original nominal geometry so that it best, right, is compensated for that particular build process that we have. Right, again, I kind of mentioned that manufacturing integration, right, kind of on the model-based definition, stage modeling kind of aspect earlier a couple slides ago, but this is where, right, additionally on the NX platform, we have that integration with, right, the build preparation, the actual additive machines, as well as, right, any sort of post-processing that may be done in terms of, right, machining off supports and again, operations, you know, that come after the actual print process. And so you're seeing kind of a sampling, right, of a few of the different technologies that we support, right, as well as kind of on the bottom right-hand graphic, right, is kind of our, right, additive build preparation application, right, where we can bring in our parts at that kind of orientation that we, right, arrived at earlier using some of those optimization tools, right. We can nest our parts, right, design supports, and kind of assign our build strategies, and kind of everything that goes into the actual production part of the process. And you're seeing kind of, again, we have a lot of relationships with those OEMs and, right, smaller print manufacturers to integrate that capability directly into NX so that we can say, right, we're going to produce this on a certain machine, right? We can set it all up, design our supports, generate our actual build files, and then walk over to the machine, load it, and hit print. So again, we're constantly kind of enhancing and expanding, right, the OEMs that we're working with to bake this capability right into NX from the get-go. So again, we kind of covered a you know, brief overview of a lot of the different design for additive tools, right, within kind of the NX portfolio here, right. We talked a little bit about kind of that core modeling capability, a lot of the different advanced additive design modules that are within NX, right. We looked at topology optimization, right. We looked at the Design Space Explorer, and again, the, right, implicit modeling, working with facet data and convergent modeling capability, right? Some of that algorithmic topology optimization, right? There's a lot of different applications that go into that advanced design bundle. But again, once we arrive at that particular design, right, we looked at a lot of tools to validate that for the manufacturing process, validate that for the actual print production process on our build simulation tools, right, as well as kind of a lot of other downstream applications with, right, model-based definition, post-process machining. And again, you see a lot of graphics here that I didn't cover, right, that kind of tie into, right, the actual scheduling and execution, again, order management, and kind of workflow within the organization, right, machine connectivity, and quality analytics, right, I did not cover, but those are all pieces, right, that kind of fold into the end-to-end additive process here at Siemens. So again, kind of just to refresh on, right, those differentiators, right, of the Siemens portfolio is, right, that kind of multidisciplinary approach using all of these different applications that we looked at, right, from, right, the optimization to the facet-based modeling, algorithmic capability, and, right, all of that's designed to kind of give you that, you know, digital thread map of what tools, right, you're using for that process. Again, finding the right tools for the job and having them all kind of baked into that one platform, right, so we can seamlessly transfer data, right, to whichever route you're looking to go. Right, the whole goal is to arrive at that first time right print, right, with a lot of those validation tools for the manufacturing process, for the actual build process, And then, right, a lot of the downstream effects of that, of right, real-time machine feedback, scheduling and execution, right, ordering and fulfillment, and kind of a lot of that other stuff that also comes in right on the execution side of additive manufacturing. So again, with the kind of design for additive tools that we took a look at today, right, hopefully you guys saw that, right, there's a ton of capability and possibility for enhancing and improving and innovating, right, with Siemens NX, where you can deliver that, right, high quality product quickly, using a lot of these different tools. So thank you guys for your time and your attention today. I'm going to kind of turn it over and ask for questions at this point.
Thank you for joining Liftoff Webinars, where we propel American manufacturing into the future.
Good afternoon. Thank you, Siemens, for an incredible presentation and very in-depth presentation. I am going to welcome Jonathan Nichols, who is joining us to answer some of the questions today. So thanks for joining us, Jonathan. I just want to recap a few great things and then get to some of the questions that has come in. Obviously, you did a great job on the entire end-to-end digital thread, the capability of NX, the validating of design, the production of performance, the optimization, all the things that are baked in, the constraints that the tool allows the geometric solutions to do, assign build strategies. It is very comprehensive. So appreciate you sharing that with the audience today. So again, thanks for joining us. So let's get started. And again, I'm going to have the folks, for those that didn't get a chance to write any questions into the chat box, go ahead and do so. But let's get started with the first one. Can you talk to me about what sort of capability is there for automated iteration of those optimization problems? It seems like a broad one, but I'm going to let you take it away.
Yeah, it kind of depends on what your definition of automated is. With the whole AI buzzword kind of taking over corporate America and just globally, a whole bunch of different people have different definitions of the term automation. In my personal, I guess, experience or opinion, James kind of touched on it a little bit. So the optimization in terms of topology, is very optimized. It's intuitive. It's automated to a certain extent. So essentially, really the idea is you just put in a couple of constraints, you put in a couple of loads on your bounding body or your design, and you press play, and then NX does the hard stuff for you. NX comes up with a design that might get you to the point where you need to be, or give you a good place to start and maybe iterate a little bit more. In addition to that, also performance predictor is a huge one, I would say. Again, just add some constraints, add some loads onto the body that you want to test, and that could go hand in hand with the top body that you generated. But again, press and play, and NX does the hard stuff for you. Generates that feedback loop. Kind of the slide that James kind of highlighted was the had like a design and a simulation bubble, and it did a nice little iteration loop of kind of describing how that would take place. So essentially, leveraging that performance predicting tool to give you the feedback, to feed it back into a design space optimization tool that we also do have. That again, James highlighted that would optimize that and automate that process a little bit more, using that feedback from the performance prediction to feed into your design space exploration. So I hope that answers the question. It's kind of like a threefold, in my opinion, three attached columns that kind of serve their their purpose in that expansion into automation and to those processes. So
Thank you for that. I think one of the things I want to mention is that this presentation will be shared after this. There was a lot of information. I mean, in the simulations that James ran through was really important. So letting the audience know that that will be shared for you to have a look at after this. I think the other thing was important that James mentioned was, how you work with all the OEM machine builders and make it user friendly. And again, I think that's important for the audience to recognize as well. Is there any thoughts or comments that you want to share on that from usefulness on the build strategies? What are your thoughts?
yeah, absolutely. So like you said, we do work very closely with the OEMs that contribute to producing those additive manufacturing machines. So a big name that a lot of people might have heard of before is EOS, or some people pronounce it EOS. We do a lot of partnering with them, especially with the aspect of their slicing tool. So how it kind of works is we're able to feed the information from their slicing tool into our NX platform, and that allows you to generate the build, generate the slicing, and all that kind of stuff. So instead of separating when you get to that point of slicing and build preparation and that kind of thing, instead of completely separating from your design tool, you're still able to operate within it, even though it is technically a separate company. That's just one example of a whole bunch of different companies. Not only connecting to different types of slicing tools and things like that, but we also we're able to pull in template files from all these different OEMs. So again, EOS, Trump are some of the ones off the top of my head. I know we deal with a couple of others, but being able to also just bring in those template files depending on what size machine. So if you're printing with EOS M400 or whatever, that's going to dictate the size of your build volume that you're dealing with, right? And instead of having to manually change that every single time, if you're jumping from a 400 to a 200 or whatever it might be, you can just bring in that template instead. So that also saves you a lot of time instead of having to manually make those changes. So
That's excellent. And I think you mentioned a couple companies, but those folks that are on the line that want to know more, I mean, that having those templates make it user friendly, but you would be happy to answer any questions, obviously post this, this webinar to answer any other specific questions. So thanks for sharing that. We do have another question come in. It says, of all the capability described in support of additive, can NX comprehend and model anisotropic material properties? I hope I said anisotropic.
like ANI, anisotropic?
Yes, okay. yes, thank you.
Yes, okay, yeah, no, that's perfect. Just want to make sure I heard you correctly through the internet and all that fun stuff. But so I know we do for a fact, I know we deal with isotropic, especially with the simulation side. The anisotropic I would have to look into off the top of my head, because I personally, when I run my simulations and the customers that I've worked with were more dealing with isotropic. I do believe there is an option. I would have to double check that before I give a absolute answer though. So I'd be happy to do the research on my end and send that back to you.
Excellent. We'll make sure that we'll make that happen.
Yeah.
So what is the best way to analyze designs for additive feasibility? Because I think sometimes that's that can be the challenge where it is designed for additive. So can you talk to me what's the best way to analyze the design to make sure it has the feasibility for additive?
Yeah, absolutely. So again, James briefly highlighted the additive, I call them additive checkers. It's essentially additive validation tools. But let me take a step back. So the topology optimization has options in its constraints to allow you to apply certain additive approaches. So you could specify, hey, I want this design or this shape or what have you to be self-supporting, or I want it to potentially avoid any overhang angles or something like that. So, or maybe fill in voids. So that's one aspect of that. Another one that James, like I said, James highlighted were our additive validation tools. So we have anything from, I think off the top of my head here, the check the wall thickness, minimum radius thickness, seeing if your design, depending on how you have it oriented on the build plate, if it will generate trap supports. So, you don't get to that point where you have it manufactured and then you're trying to machine the supports off and it's in a little, one of the supports is in like a little crevice that you can't reach with your, maybe your 5-axis. So you have to take a hammer and a chisel and go in and knock those things out. So we have different aspects like that that allow you to do analysis, and we also have additional aspects in NX along with those validation tools that allow you to potentially optimize the orientation as well. I think also James touched on it, but it allows you to take those validation tools and a lot of others that I just highlighted and bring that into an optimization orientation wizard is kind of what I refer to it as. You put in a couple of criteria, maybe what you define as your overhang angle. So whether it's 40 degrees, 45, whatever it may be, specific things that might cause overheating, those kind of aspects, run it through the wizard, and then it gives you a bunch of different orientations that you can send to the printer to help you optimize those aspects. So if you wanted to maybe minimize support structure that is generated for that print, or you want to minimize the amount of surface area that the print is going to take up once it becomes oriented onto the build tray, those all get digested by this wizard along with other things like the overheating, that kind of stuff, and it spits you out a couple of coordinate systems that you can choose from. And so those kind of combined together, I would say, attribute to allowing you to validate and design, make sure that your design is ready for the additive manufacturing portion, right? Because there are some designs that aren't specifically designed for additive, and then there are designs that are specific for additive. So those validation checkers really come in handy, and I use them more than I can count. So
I'm sure that's great to know, and it sounds like with what you have within this wizard feature and these templates, obviously make it very beneficial for those folks that are looking to adopt and accelerate their additive manufacturing. So any other tips or tricks that you want to share? That's all the questions that we have coming in, Jonathan. So if there's any other closing comments or that you want to share about the the Siemens suite of tools on this end-to-end digital thread solution, I'll let you do that now, and then I'll close us out after. So any closing comments?
Yeah, absolutely. So the one thing I do want to highlight is that James shared it at the beginning of his presentation and towards the end as well, is that full-on digital thread. So, as far as the additive manufacturing aspect goes and beyond additive, whether, you're in aerospace and defense, or if you're in marine, or, whatever industry you might be in, whatever manufacturing process you're trying to tackle, Siemens does handle the end-to-end. So from start to finish, using that design, working from design to simulation into manufacturing, and even generating that feedback loop with Q&A and insights and things like that to essentially allow you to iterate better the next time that it's time to design again. Siemens can feed into that. We have a whole bunch of different industry verticals, a whole bunch of different digital threads. So let's just take, because we're on the topic, the additive manufacturing thread, for example. James did a really good job of taking y'all through the design, the build prep, the simulation portion, and he did mention this, but I also want to just reiterate it. It doesn't stop there, right? It goes into manufacturing execution, it goes into quality and analytics and trying to figure out, hey, send this over to research and development and get some feedback back on that. What material combination, what material mixtures, if we're dealing with powders or what have you, will print better the next time. And Siemens can feed into all of that. So just wanted to highlight that. But yeah, I'm really glad that everyone hopped in today to learn a little bit more. And I really think James did a killer job, if I do say so myself. So that's all I got.
All right, Jonathan, thank you. I'd like to thank all the attendees for joining us today on this liftoff webinar. So Siemens, Jonathan, James, thank you for being a great partner, great member of LIFT. We appreciate your contribution and collaboration with us to advance this amazing manufacturing industry that we're in. I'd like everybody to mark your calendars for September 25th, our next liftoff webinar with North Florida Economic Development Partnership. Have a great day, everybody, and a wonderful Labor Day long weekend ahead of us. Thanks, Jonathan. Thanks, everybody.
All right. Thank you all. Glad to be here.